Hi and good evening. We are from Group 4 and now we are going to present about our Geology Engineering Group project. First of all, I would like to introduce our group member. First is Xia Xiang Feng, second is me, Wizi Kwan, third is Tam Musin, and fourth is Goh Jun Hong.
Doctor, my name is Xiaxiang Feng, and I representation the introduction part. So, the geology engineer is an essential subject in the civil engineering program, which requires students to complete it for their bachelor degree. So, the students will have conduct the site investigation to study the rock types, classifications, and determine the rock mass rating, which is RMR. So 4 site visits were carried out in this project were Air Hitam, Kampung Air Puteri, Tanjung Mensang, and Pantai Pasir Langu. During these visits, students collect rock samples and imported data, and these samples and data will be used for future laboratory tests and calculation as part of the course requirements. So, the objective of project have 3, which is to oppose the practical application of engineering geology theory through field investigation and tests. Second, to identify mass structure and classify the degree of weathering of rocks, observe discontinuity data to analyze rock slopes stability using the stairnet method and determine the strength of rocks found in the visited area. And third, to produce graduates who have a high knowledge base in engineering geology and its application. So, in description of project, where 4 site visits will have in this project. So first site visit, which is in Air Hitam, Johor. Our first site visit was to Air Hitam, Johor, where we'll collect data on rock type, rock formation, the direction, the angle, and conduct the Schmidt rebound hammer test. The exposed rock formation was classified as metamorphic, like shears or jeans, which identify by its formations in clay structures and fractures, which indicates transformation under heat and pressure. So the second site visit, which is Kampung Eputeri Masjid. At site visits, we visit a sea sites characterized by marine erosion zones where continuous wave action shapes and exposed dark, fractured like igneous rocks such as basalt or andesite. These volcanic origin rocks form from solidified lava or magma and are typical of coastal in Peninsular Malaysia. So the third site visit, which is Tanjung Vesang Mersing. Originally planned for Pasir Langu but changed to Tanjung Vesang due to crowding. The visit focused on the rockside cliffs, displaying clear horizontal layers, typical of sedimentary rocks like siltstone and sandstone. These rocks showed the fine texture, brittleness, and were composed from various minerals, with quartz and feldspar as dominant components cemented by calcite, silica, or iron oxide. So in 4th site visit, which is in Pantai Air Puteri Masjid. At site visits, we identify 2 types of igneous rocks, granite and basalt, based on their color extraction. The rocks exhibit a rather brownish appearance with visible mineral variations, and granite shows well-developed joint patterns, including systematic and cross joint.
And now we are going to present about methodology for this group project. So first of all, as we all know, we are going to a trip in Mersing. So the first one is site visit and geological mapping. So the first site that we go is in Air Hitam, the second is in Telok Iskandar, Mersing, and the third is a slope beside Jalan Tanjung Resang, and the fourth one is at Pantai Pasir Lanun, Penyambung. And at each site, we have identified the rock type and also geological structures with the help of geological mapping because it stated the characteristic of the rock in that area. For the second part, weathering grade classification. So we determine visually by comparing the observed rock characteristic with the help of ISRM 2007 as stated in the slide to determine the strength and condition of the rock to identify the slope stability later. For the third part, discontinuity mapping, also known as scan line survey, so we have carried out in 4 sites, but in site 1 and site 3, we have detailed scan line survey because it requires RMR analysis, rebound hammer test, sampling for lab tests, and also slope stability analysis. But in Site 2 and Site 4, it only requires to identify the geological structures and also the rock identification. For the fourth part, in order to analyze and calculate the RMR, which is the rock mass rating, we require the RGD, rock quality designation, that we will be shown in the result part. And the second one is spacing and condition, where we assume the shape or the texture in based on our slope. And the third one is presence of groundwater seepage. And the fourth is rebound hammer test. Okay, after we determine the four parameters just now, we can evaluate it using the rock mass rating system and also uni-axial compressive strength classification. And lastly, we can determine it using the rock mass class, and we can know that the rock is a good rock or bad rock. So in the fifth part, in situ testing, we have explained the last part that rebound hammer test is used to calculate the RMR. So in this part, I just briefly explain how it works. So it's used to estimate the compressive strength of the rock in the site. So we just have to push the hammer firmly and perpendicularly to the rock, and we will get the data, but we need at least 9, so we just have to draw a box of 9 and just push the hammer to get the result. After that, we just have to calculate the average, and we can get the result, but we will use A in this case because it is horizontally. For the sixth part, laboratory testing, after we collect the rock sample from the site, we have to conduct the test in the lab, which is point load index test, and is used to determine the uniaxial compressive strength of our rock sample. And this is the machine for the test. And for the last part, slope stability analysis. We use the discontinuity data such as tip direction and tip angle we gather in the site, and use the app, which is Field Move Clino, to generate the stereo net so we can uh, analyze it easily.
Good morning, lecturer. I'm Gu Junhong. So now I'm going to talk about result and discussion for Site 1 and Site 4. So for Site 1 is located at Air Hitam Johor, and this is the site photo and scanline discontinuity mapping for Air Hitam Johor. And based on scanline discontinuities mapping, we can get the discontinuity set. And by using Smith rebound hammer test, we can get uniaxial compressive strength, and this is the table that we get. And the average compressive strength is 32.33 MPa. So therefore, the rod in iHitam are classified as a medium strong class in compressive strength based on the table that Zikwan has already said. Okay, so for rock quality designation, RQD was determined by using the following equation. RQD equals to 115 minus 3.3 JV. So to calculate the total number of joints per meter cube, which is JV, we can use the formula JV equals to 1 over L over S1 plus 1 over L over S2 plus 1 over L over S3 until 1 over L over Sn. And the total number of joints that we get is 4.258 per meter cube. By substituting the total number of joints into the equation, we can get that our QT equals to 100. After that, for the spacing of discontinuity, the average spacing can be determined by using the equation of SA equals to S1 plus S2 plus S3 until Sn over the number of S that we use. And we get that it is 11th. Okay, so for the rock mass rating system, we can get that the result is total rating for this item machine is 79, which is classified as good rock category. This is because it has high RQD value of 90% until 100%, and it has moderate point load index 1 to 2 MPa, optimal discontinuity spacing of zero point 0.6 until 2.0 meter, slightly roof surface separation of lower than 1 mm, slightly weathered walls. After that, it also has completely dry groundwater conditions and no adjustment for joint orientation.
Alright, for the site 2, which is located at Teluk Iskandar, Mersing. The primary rocks types are phyllites and quartzites, both formed through low to medium grade regional metamorphism. Phyllite is fine-grained with a silky sheen which is phyllitic luster due to a light mica minerals and often retains traces of sedimentary layering. Quartzite, formed from quartz-rich sandstone, is hard and dense with interlocking quartz grains, making it highly resistant to weathering. These rocks commonly occur together in metamorphic sequences, reflecting varying original sediment types. And at the bottom left is the picture of phyllites and quartzites, following by scanline discontinuity mapping. And for at this site, we have observed some geological structures, which is bedding and faults. For the next site, which is a slope beside Jalan Air Papan to Jalan Tanjung Resang. For the picture at the left side is our study area, which is 1 meter times 1 meter, and following by the scan line discontinuity mapping, and using it, we got to determine our discontinuity sets. And this is the uniaxial compressive strength that we obtain by using rebar hammer test. And the average compressive strength is 14.11 megapascal. Therefore, the compressive strength of the rocks that we obtain at slope beside Jalan Air Papan to Jalan Tanjung Resang are classified as a weak class in compressive strength. For the rock quality designation, our QD for S1 is 3 and S2 is 5. By using it, we got to calculated our number of joints per meter cube, which is 0.53. And for the average compressive strength, the accuracy is 100 because the JV is lower than 4.5. And the spacing of discontinuities is 4. The rock mass rating R&R for slope beside Jalan Air Papan to Jalan Tanjung Resang has a total rating of 72, which is classified as very good rock category. This is because it has high RQD value of 90% to 100%. Uniaxial compressive strength is 5 to 25 megapascal. Optimal discontinuity spacing of 200 to 600 millimeters. Slightly rough surface separations of lower than 1 millimeter. Slightly weathered walls. Complete dry groundwater conditions and no adjustment.
Thank you, Musia, for his excellent explanation. So now I'm going to continuing for Site 4, Pantai Pasir Lanun, Penyabong. So the rock type at Pantai Pasir Lanun, Penyabong is pyroclastic igneous rock, which is formed from volcanic eruptions, which consisting of fragmented materials such as ash, pumice, and other more. They belongs to explosive igneous rock because they form from the cooling and consolidation of volcanic materials near the Earth's surface. So this is the photo for pyroclastic rocks, and this is the scale discontinuity mapping for Pantai Pasilangan, Penabong. And for the geological structure that we observe at Site 4 is joints and faults.
In conclusion, we gain valuable knowledge and experience about igneous, metamorphic, and sedimentary rocks during the trip. We observed different forms of weathering at Air Hitam, Kampung Air Puteri, Tanjung Resang, and Pantai Pasir Lalu. Through the trip, we learned to recognize and identify rock types in the field, such as granite at Air Hitam and basalt at Pantai Pasir Lalu. Also, we study force, joints, and structural features, and also record the walls mapping readings and rebound hammer readings at WSM. In this trip, we improve our understanding of struts, faults, and force, and get some practical skills with tools like the compass. We also learn the importance of teamwork, patience, and collaboration while making new friends and sharing knowledge. Overall, it was a fun and rewarding experience, with each day bringing something new to enjoy and learn. So that is the presentation for our group. Thank you.